let's get to covalent compounds now. So for the covalent compounds too, we are just going to start with those that containing only two elements. Like yes, two elements in the covalent compound. What do you say in covalent compound? Covalent compound, co means like cooperation, sharing, some kind of sharing, some kind of agreement between two things, right? So like co-founders. So co-founders are people that share the same thing, like they work on the same thing together. So we say covalent, right? Covalent, these substances, these atoms are sharing their valence electrons. They are sharing their valence electrons in the body. Unlike the ionic bonding where the metal completely transfer the electrons from the metal to the non-metal. But for covalent compounds, then they are sharing. They are all covalent, so they are sharing their valence electrons in forming the bond. That's about the covalent compound. Now, binary covalent compounds mean that we are just including two atoms from two different elements. Atoms from two different sources, from two different elements. That will make it a binary covalent compounds. In naming this, we need to go back to our periodic table again and then focus on the element that we said all the time. Like I kind of put together for you that we are going to be focusing on. Yeah, it's still this element. So here, the basic thing you have to know about them is that they are going to be bonds that contain only non-metals. Only non-metals are going to be forming this bond. Not like the binary, we have a metal and a non-metal, where you have the covalent, ionic one. But then for covalent, right, all the atoms inside the bond, right, are basically going to be non-metals all the time. They are going to be non-metals. So all these ones that they put together, they are the ones that will be present in the bond that we are going to form. So now, how to name them now that the two of them are in the same bond, like the two of them are covalent, and then the two of them are non-metals, and then they are in the same bond. How do we name them now? So if you follow the previous video where we talk about naming of metal type 2 elements, right? So yeah, we are the same process. We are going to do the same process. But then one of the non-metal in this case, since they are all non-metal, one of the non-metals in this case is going to stand as a metal type 2. It is going to stand as metal type. It is not a metal type 2. It's not even a metal. It's a non-metal. But in a bond where you have a non-metal and another non-metal bonding together, and then they are in a binary, one of them is going to act as a metal type 2, and the other one will just act as a normal non-metal. That's what we have at the back of our mind, but we know that all of them are metal type non-metals. Now let's look at some example to illustrate the example of what I mean. So the very first example that we are going to look at is CO. So CO is a binary covalent compound. Why covalent? Because these are non-metal. Carbon is a non-metal. Oxygen is also a non-metal. So they are this is a covalent and it's a binary covalent. But then one of them is going to act like the the metal type 2. The guy that is going to act as the non-metal is the first one that always comes. So it takes the position of where non-metal is supposed to be. Remember when we did something like FeO, the metals come before the non-metal. Metals come before the non-metal. Why would they give you a binary covalent compound where every one is a non-metal, right? Then the one that's going to act as the non-metal, as the binary metal type 2, is going to be the very first one. So in this case, yes, we don't have a metal, but then carbon is going to be our metal type 2, quote unquote. So right, so now how do we name them now? We do go to the same process. So here the frequencies are 1 1. So the number of times they appear are 1 1. But then how do we know? How do you calculate the oxidation number? Right, 1 times x. That's for the carbon, from the carbon, because carbon is going to be in the place of this thing. But then for the oxygen, we know from previous session that is negative to equal to 0. Why is it equal to 0? Because the net charge on the entire species is 0. There's no negative 2 minus or anything at the top finally, but then there's nothing here, so the electrical charge is 0, right? This is how you need to calculate the air. But then how do I get this? Again, you see carbon is 4 minus, nitrogen is 3 minus, oxygen is 2 minus, F minus, Cl minus, all the group 7, I minus is also there, P is 3 minus, sulfur is S 2 minus. Notice that when they are acting as at the place of a metal type 2, when they are acting at the place of metal type 2, These guys don't hold. These guys don't hold. These charges 4 minus and this is not hold for them. But then those guys that come second, they still maintain their 4 2 minus and this stuff, right? So someone will say, okay, we have carbon here and we know that carbon is 4 minus. Why are we not picking this 4 minus? But we are rather calculating for it. So just know that formula type, know that you have to follow the previous section to understand this one, right? If you're in binary covalent compound, right, and this guy, the one that comes first, the non-metal that comes first, right, doesn't necessarily have to be any of these charges at the top here. You have to calculate it, right? But then these guys that are second, the one that comes after, they maintain whatever they have here. So it means that if oxygen had come first, we wouldn't use 2 minus. If oxygen, like we have OC, if oxygen had come first, we wouldn't use the we will not use the 2 minus. We will have to calculate for this guy and then use the 4 minus for this. But this thing doesn't exist like that. The compound will give you carbon and then oxygen like this. So now let's continue. We're going to be x plus into bracket negative 2 equal to 0, x minus 2 equals 0, s is equal to plus 2. So how do we name this one? So carbon is going to be carbon. We are not going to use the base name. Carbon, how is it here? 2, right? Carbon 2 oxide. Carbon 2 oxide. This is what we have. This is the name for CO. Carbon 2 oxide. Yes. So the carbon in this case, again, I said they are going to act like metal type 2. For metal type 2, you write their full name there. You write the full name of the metal, the oxidation number, and then the non-anion this thing. But then, yeah, that's basically what you follow. You don't use the IDE for the first one that appears. Okay, now that you've taken that, let's solve more in order to solidify this concept. Let's look at another one, CO2, our popular one, CO2. So I'm having this one is going to be 1 times x, 1 because its frequency is 1, the frequency here is 2 for this one, plus 2 into brackets, negative 2. So you have to know for us equal to 0 because everything is 0. So you have x minus 4 equals 0. So s is equal to 4. This is carbon 4 oxide. Roman numeral, you need to know the 4 and those stuff. Right? So revise your Roman numeral, yes, you will be fine. So carbon 4 oxide, this is carbon 4 oxide. Let's add more examples. Don't worry, so the number of them. Then the next one is N2O. This is another example. So let's just solve 2 times x, right? This is going to be like the non-metal plus 2 into bracket. Hey, no, not 2. This is very bad. This is 1. Oxygen is 1. So it's 1 times negative 2. It goes to 0. You know where the negative 2 is coming from, right? Okay. So you have 2x minus 2 will be equal to 0. So 2x is equal to plus 2. So s is equal to plus 1. So is this going to be nitrogen 1 oxide? Nitrogen 1 oxide, as simple as that. Yeah, that's that is the naming. Don't worry, we'll solve another one. Nitrogen 1 oxide. Let's see, PCl3. So P is 1x plus 3 times chlorine is negative 1 because it's group 7, right? Equal to 0. 0 because the entire is charge is 0 minus 3 equals 0. X is equal to plus 3. Then you are just going to have phosphorus. P is phosphorus 3 chloride. The anion name chloride. So this is for this species. Now another example. Oh, we solve more examples. SF6, right? So SF6 is an example. So we're going to 1 times x. The 1 is coming from the frequency of this square. If it is 1, we don't write it. That's why. Plus 6 times f is 7, so negative 1 equals to 0. So it's like x minus 6 equals 0. So s is equal to plus 6. So it's going to be sulfur 6 fluoride. Yeah, fluoride. Yeah, as simple as that. Support 6 fluoride. So you just follow the rule. Just follow the rule in naming this kind of covalent binary covalent compounds. Then I have another example. I have NO. This one will be 1 times X, right? 1 is coming from the nitrogen plus 1 times -2 equal to 0. So X will be equal to plus 2. So this will be nitrogen 2 oxide. Nitrogen into brackets 2 oxide. Don't forget this bracket. Oxide. This is the name for this particular species. I have more examples for you. So anytime I write one, you can pause the video and solve it, and then see if you can get it correct and mark yourself. Plus 2 into bracket -2, right, equal to 0. So you have S will be equal to plus 4. So this is nitrogen 4 oxide. Nitrogen 4 oxide. Great. Yeah, if I'm putting the ball like that, it means that I have more examples for you. I have Cl2O. It's going to be 2 times X plus 1 times -2 is equal to 0. So 2S minus 2 equals 0. 2S is equal to plus 2. X is equal to plus 1. So it's going to chlorine 1 oxide. Chlorine 1 oxide. That's the name for this species. Yes, another example is coming. Pause the video anytime and then solve it on your own and then see if you can get it once you got the first 3 examples. So I have Cl2O7. Yes, that's what I have. So let's see how we name this one. So it's going to be 2 times X from the chlorine plus 7 times -2 from the oxygen, 0. So we have 2x minus 14 equals 0. 2s is equal to plus 14, and then x will be equal to plus 7. This is chlorine 7 oxide. Chlorine 7 oxide. Yeah, that's what we have. This last one, I'll leave it to you to try. Try on your own. Try on your own and get the answer. This is N2F4. N2F4, right? That's the example I am having for you. So you can pause the video and try it, and then this is the last one that I have for you to do. Pause the video and try it and see if you can name it. But then if you got it, if you have done what I said, pausing the video and let's solve it together. 2 times X, because nitrogen is going to be our non-metal. Oh no, sorry, our metal type 2, but it's not a non-metal. We are just using that logic to be able to name it. -1 is equal to 0. Negative coming from the chlorine because it's 7. And you 7 have the charges -1 or the number of -1. So we have 2x minus 4 equals 0. So S, if you do it, S is equal to plus 2, then you have nitrogen 2 fluoride. Yeah, that has been a chunk of examples that was done so quickly. You'll be quick like that if you also master. The thing is just understand the business, understand the rule. What am I supposed to do? Right? What am I supposed to do? Just understand that, and then you'll be fine. You'll be fine. So this is how to name binary covalent compounds. So yeah, we know meta type 1, meta type 2, and all that now. Now we are going to be naming ions now from here. Let's see what happens in the next session. See you there.